Today we're going to talk about the hot 5500 SC Silica Analyzer. So before we even get into that, the hazards associated with this are obviously the chemicals and the pressure that it uses for a motive force for the chemicals, which is an air pump. So these bottles are under pressure when this is in operation via the air pump. So anytime you open this door, it's going to release the pressure off those. But before you do all that, first make sure that you know where the eye wash station is, and make sure you got the proper PPE on. Which, if you're going to do a bottle change, just go off the SDS sheets. But since we're not going to do a bottle change, we're just going to go over the operation of this analyzer. We're just going to continue on. But I guess we'll start with the basic operation of this analyzer. So the sample comes in, and these are arranged in a different way depending on the analyzer you're working with. But it first goes to a flow meter, and around 100 milligrams a liter is typically where you see those, and that provides plenty of water for sample. It goes through a strainer and then a pressure regulator, which is factory set at 4 to 5 pounds, somewhere around there. And then it goes into the back of the analyzer through these ports right here. And these analyzers are set up to where they can alternate between different samples. This one right here is only going to be sampling one source, but it's set up where you can alternate. And it has there's solenoids involved that alternate between those sources. So from there, like I was saying earlier, this uses the air pressure to pressure these bottles up. The reagents and the standard, or not the standards, or actually yes, the standard too. Except the reagents go to these solenoids right here, and the standard goes to this solenoid. This bigger hose right here is the sample. So all of these are pressured up to these points right here. The chemical addition is controlled just based on time. The pressure remains constant, which is 4 pounds on the air pump, on the air pressure. So these solenoids will open based on time. That's how it works. So that's why the air pressure is really important. It needs to stay consistent, and that's also why the sample pressure needs to stay consistent. So that's pretty much it on the operation side of things. Most of the, I guess I can talk about it here. So once the sample is filled, there's a stir bar in there. So it'll fill it, flush, and then that stir bar will run after the chemical addition is made and mix everything up well, and then it's analyzed. And then the cycle starts all over again. It flushes with the sample. The sample is actually flush water too. And then it starts all over. These are set up to do, they can be set up to do a 15-minute time frame or a 30-minute time frame, depending on how much you want from it, how many times you need that sample, and how much you're willing to spend on chemical usage, I suppose. But the major issues, I guess we'll talk about some of the main problems, the common problems. Sometimes I'll remove the door just for ease of access. Are after bottle changes. That's probably 90% of the issues that you'll have. After bottle changes, there'll either be an air leak or the reagents won't be primed. And the way to prime the reagents, so let me go through the bottle change real quick. When you open this door, you see it goes into alarm. Right then when you open the door, it automatically dumps the air pressure off these bottles. So that's a safety feature within the analyzer itself. So now these are no longer under pressure. and you can change the bottle. So say we just changed the bottle out. Make sure the caps are tight, make sure these are tight. One of these is for the air, one of these are for the chemical. So once the bottle's changed, if you just swap a bottle like that, put it back, there's going to be either several of the next runs are going to be faulty or bad, or if it's a calibration bottle, a standard bottle that you've changed out, that calibration can fail. You can see how you always got the last cal value. That standard is a 500, so it should be somewhere around a 500 on that cal value. That's pretty good. Not one of the best, but it's okay. So it could get a 20, or who knows, it could be way off if somebody just swaps the standard bottle out without priming it. So what you should do after you swap the bottle out, go to menu, reagents and standards, and if you replaced all the bottles, you could just reset the standard levels. So that what that does is, see down here you got all the levels. That's not measuring anything, it's just a time based on how many times it's sampled, it calculates that. So they're not always correct, and if somebody changes the bottles out and doesn't reset it, of course it won't be correct then either. If you go here, after we've set the reagent levels, and then prime the reagents. So let's just go through that. We got all of them selected, and here in a minute I'll show you what it's supposed to look like.